Hello and welcome to the final webinar of our 8-week webinar series called Advancing in Predictive with Alteryx. We have really enjoyed this series and are excited to be wrapping things up with time series. A few notes before we get started is, yes, this webinar is being recorded and the link will be available before the end of the week. And we will have a Q&A session at the end, but you are more than welcome to submit your questions in the Q&A panel as we go along. There is a file download for this webinar, and I'll be sharing the link in the chat box as well. So a few introductions. My name is Rachel Mason, and I'm the marketing specialist here at Teknion Data Solutions, helping out with this series, and Teknion is happy to be hosting. Today's webinar will be covered by Dr. J. Kyle Roberts, who is our data scientist here at Teknion Data Solutions. A little bit about Kyle: he's held professor positions at SMU, Baylor College of Medicine, and the University of North Texas. He also co-authored the White Hat package in R, and he is an expert in multi-level modeling and co-authored the Handbook of Advanced Multi-Level Analysis. So without further ado, I'm going to hand it over to Kyle.
All right, thanks, Rachel. So today we're going to be talking about time series, and so time series is tough. We could easily take 4 to 6 weeks to talk about this and all the different nuances. And so let me be clear at first that what we're trying to do here is just give you an understanding of kind of how the tools work inside of Alteryx. We're not going to be covering covariates today. Just there's a lot of statistical thought we have to put into that. So I'm not going to cover that in today's, but maybe we'll do that in the future. But also wanted to see kind of where the files are, and there's just one data file for today. That is a simulated data set that I've created that will give you the ability not only to walk through what we're working on right now, but also the ability to do some more modeling later on. And so it's kind of a fun data set that I'll show you. But then also wanted to let you know, and again, we remind you of this every week, Teknion is very committed to the Alteryx community and providing free resources for you. And so if you wanted to go to the Teknion website and look at the predictive macros. So all you would do is just navigate to the screen that is for Alteryx or the Alteryx page. And then down at the bottom of that, we have a bunch of predictive macros and then other macros too in a toolkit that we're developing. And we add stuff all the time, and we're actually working on a principal components tool that will actually extend Alteryx a little bit further. So just wanted to make sure you knew those are available. And again, we're committed to providing those for free to the Alteryx community. So let's talk first about time series data structure, because this is the most important thing, and I think where people get hung up when they're trying to do time series is really what data look like. And the reason is that most of the time when you have data in your data set, it generally looks like this, that you have some wide data structure where you have each column represents, let's say, a specific time point. So this case, January, February, March. And then, or it may contain a date like, 2019, 12/01 or something like that contains the date. So the issue is that while this is acceptable for kind of monitoring data across time, and it's definitely easier to understand how data work, and how you can consistently be adding data into a database, just by saying, all right, well, let's timestamp this column and then give me all the variables that I care about. When you're running time series analysis, you can't analyze the data this way. We actually need what's called a long data structure. And so so in this case, what I've done is just kind of done a simple transpose here of taking this wide data, turning it into long data. And again, if we wanted to, we could just use our simple tools inside of, going back and forth between wide and long with the transpose and the crosstab tool inside of Alteryx to convert this from a wide format into a long format. And again, if time permits, I'll show you how to do this at the end. But it is important. Data has to be structured this way. And also too, I will say that Alteryx, for the most part, it is nice if you have that date column in there, although it's not 100% required. but it is good practice to go ahead and leave a date column in there. You could just have the scores all in there and you could still run your analysis, but we typically like the date alongside that just so that we know we're making sure that we're analyzing the most recent data, okay? So second thing is that time series modeling, there's multiple ways that we can do this, and I'm just gonna hit the high points on 3 of these ways, and then we're gonna illustrate 2 of them. So the first is that we can do time series modeling in something called ARIMA, and ARIMA is a term for autoregressive types of analysis where you're noticing that and again, I'm going to use those statistical ease here, you're noticing that your error structures are very correlated across time. And so meaning that you kind of are introducing the same sources of error at each point in your modeling procedure. And so in this ARIMA, this takes it into account. And so we typically use an ARIMA type model when your future forecast depends really just mostly on the most current or most recent observations. And so we're saying like, okay, you may have 100 days in your data set, but really what we're going to do is really use the last 7, 10, 14 or whatever days in order to predict the following 7. Okay, now that's juxtaposed to ETS. And ETS is really used when we're doing more of a trend. We noticing that there's some sort of environmental trend in our data, or we're noticing seasonality among our data. So this is the easiest way, I think, to think about this. If you are looking at a data set in which you notice, hey, there's lots of seasonality, you probably want to go ETS. And when you're just using data where you're noticing, no, it really just is depending on what's been going on for the last few days. As to the predictive future, we typically want to use ARIMA. Or another way to think about this is that I would like to use ARIMA when I'm predicting stock forecasts, because they usually don't go through seasonality. It really is kind of all what have you done for me lately in that stock. And I might use ETS when we're doing like sales forecasting for different items that we have, let's say in a store, and we're noticing, hey, there's seasonality trends at Christmas. Or let's say we had a sportsman supply store, and all of our camouflage clothing typically sells really hot around October to December. Okay, so we notice that seasonality. So that's when we would want to use ETS. Now there is another type called multi-level time series. This isn't available in Alteryx, but I did just want to hit the high points on this because this is used when you have something called time varying covariates, meaning you are predicting. You're using variables to predict change across time, and this is different from a covariate in ARIMA and ETS. This is more of a predictive model that you're saying those covariates are really influencing and they change across time. So the covariate being like, let's say you're trying to model stock price of one stock price, but you're also using changes in other stock prices to help model why that one stock is behaving the way it is. So that's something that's varying across time, and you want to include that in your model. You'd have to go to a multi-level type setting. Again, you can't do this in Alteryx. There are specific packages for doing this, so you could do it in R, you could do it in Python, SAS, M+, you could do it in MLWin is another package, HLM is another package. Okay, so there's packages that are software that are specifically designed for this. Okay, also too, time series modeling is hard. And so I wanted to give you, this is a really great resource. This is far and away my favorite book for time series. Called Applied Longitudinal Data Analysis by Singer and Willett. I don't know John Willett, but I do know Judy Singer. She is wonderful and just an amazing researcher who wrote a book that's really easy to understand. And then they also have everything they do in their in this book. There's a resource that's at UCLA that has every single graph that they make, every analysis that they run. They show how to do it in multiple software packages. So if you are looking to really advance your skills in this is the book worth buying. So there's other books out there, but for definitely for an applied researcher or an applied analyst, this one's my favorite. So far and away, really, really great book. Okay, all right. So let's switch over to Alteryx and let's start working with some of the data that we're going to see there. Okay, so I'm going to open up open up Alteryx real quick, and I'm going to pull that data set in that we have made available to all of you. As soon as my screen stops from being locked up. So not sure why that just did that. But anyway, as this is coming up, we'll also give you some opportunity to pull in that data set. So here we go. Okay, so this data set is one that I've made for y'all. This is we want to think of this as let me go ahead and run this or refresh this so you can see it. Oh goodness, Alteryx just kind of flipped out on me. So this data set initially is a really long data set. And what we have in here is we see there's a timestamp for the date time. I'm really looking only at sales, but I've included some things in here that will allow you to play with this more later. So there's quite a few items that are in here, and then I have their sales nested inside different stores. And the reason I did this is I want you to be able to go in later and say, oh, well, let's do the same analysis that Kyle ran, but let's do it just for item 2 and in store number 7. So you can play. So there's lots of opportunities to play, but really we're going to care about this variable here, sales. And then the store by item variable is a variable that I just created that's just a concatenated which store and which item did it come out of if you needed to use that. And then there's my date timestamp. Okay. Now, the first thing that you're going to need to do, as with all data, is always pull a select tool in just so I can see what the data look like and what structure they're in. And so in this case, if you'll notice, store, item, and sales are actually, they came in as a string, and I'm going to convert those to double date. Actually, Alteryx recognized that as a date. So we are doing good there. There's no real issue there. And then that we're going to have to worry about. And then what I'm going to do is I'm putting 2 filter tools on after this. And the first one is saying, hey, just grab item number 1 and store number 1. So that's how we're going to do our analysis. And then I'm also creating a little bit of a holdout. And the reason I'm doing this is because my data right now go all the way through the end of 2017. And so what I'm going to do is in my analysis, I'm going to use all of the past data to predict the data forward from from December 16th forward. So I've said, date time is less than or equal to, and then later on, what we're going to do is we're going to predict those 3, and that's those 2 weeks, and that's going to give us a good means by which we can tell, all right, what we're looking at is running better in ARIMA or better in an ETS type setting. And so I think the first thing we want to do is, now I know what this data look like, but of course you may not. This may be your first experience with this, with its data set. And so as this comes up, I'm going to pull in my ARIMA tool, and I'm going to set it right there. Actually, I'm going to pull it up here because I'm going to put ETS down below it in just a little bit. So let me pull in that connection. And how we set up this tool, we're just going to use a simple way. We're going to call this model name, we're going to call it ARIMA, and then the target field is going to be sales. And if you remember from the data set, I have data that are coming in. Let me refresh that again. I have data that are coming in daily. So you can see there's 2013, 0101, and then 0102. So in the ARIMA tool, I need to reflect this also. Daily, and I'm doing all days. Now, the reason that this is important is because we need to specify for when we start doing predictions in the future, what do our data look like, and then how would the data look like going forward? So it may be if you're in a retail location that's only open Monday through Friday, then you would do daily and weekdays only, okay? But it may be odd. Let's suppose you have let's suppose you're working at Chick-fil-A, or you're looking at that analysis and they're closed just on Sundays. That would be in an instance where we would use this TS filler tool that would actually, we would be able to use that to populate that there was also a Sunday in there too. And so I'm not going to go into that again just for time constraints, but Alteryx does include this great tool in there. So if you did have someone that say open 6 days a week, then you could actually work based on that, okay? The other thing, the other options is that this number of periods to include in the forecast, I'm going to change that to 30. So what this is this is kind of weighting in a weighting the data in a forecast to say, all right, how far back do you want to go in order to use to forecast forward? I say we did 30. Let's do 14 instead. And we're just saying in a forecast plot we would forecast out 14 days because that's the number of days that we're going to actually leave out for right now. Okay, so then I'll right click here. I can add all the browses, and then I'll go ahead and click on run. After that comes up. Again, I'm not sure why Alteryx is running slow on my system today. There we go. All right, all the browsers are there. And I am experiencing some type of issues there. So we will wait for this to, oh my goodness, there we go. All right, Alteryx flipping out on me. It may be that I've just gone to a newer version of my Mac operating system, and so having some issues there. Okay, but as this is coming up, so again, you can see I have 913 rows, or 13,000 rows of my data. We're splitting that down to just item 1 and store 1, and then I'm leaving the last 14 days out of my data set, okay, or last 15, I guess, because it goes through 31st. All right, so let's look at what our results look like, and we'll talk through this for just a little bit, okay. So as this first comes up, here's kind of the part that I care about. That first anchor that comes out of there is just the output. We're going to use that later to kind of compare models. So I'm looking at the second anchor, and let's see what we can see here. Okay. So the results of this model give you information that may or may not be helpful to you. Okay. So the coefficients for an AR1 structure are SMA1, and so these are kind of like the way that it's looking at weighting the different lag functions, which are how far back we go and how much we want to weight each way. So for the most part, unless you've read that book that I recommend, I would just kind of leave these coefficients alone. This AIC, this is a Kaki information criterion, this is a Bayesian information criterion. Those things, we're going to kind of leave those alone because we're going to use them later, and those are really good metrics for helping us compare two models to each other. And generally, the lower the value, the better the modeling is. And again, here's our error structure. So you may be familiar with RMSE. That's a root mean square error. That's going to be helpful. The MAPE is also going to be helpful in comparing models to each other. And then we get down to these plots. And here's kind of the interesting part. When we see a true ARIMA style model, generally what we're going to see is that the plots, what these are looking at is these lag functions across how many days of observing that we're seeing. So if you can tell here, if we are, and if you can see my cursor or my pointer, typically in an AR1 structure, we kind of want to see, all right, there's some same, there's kind of a slowly trending down that the relation between earlier example or earlier structures and later structures, they tend to, you tend to be less dependent on those as we go across time. But what we're seeing here is that there's a lot of up and down, and then when we get 21 days out, we're seeing some pretty huge lags that are really way outside of bounds that we would normally consider, all right, that's a normal area. And what this is telling us is that we're seeing some seasonality in here. Now we can actually see that seasonality in other plots too. And so if we were looking to these plots, this will give us a really good idea of that seasonality component. And when you start to see the data, now you'll see kind of what I'm talking about. So if you want to think of from here to about right here, that's about a year. And then there's about another year, and then there's about another year there, and then there's about another year there, and then here's another year, and then all the way here at the end, those are the 14 days that we're actually predicting going out from here forward, so from that area forward. And so again, if I just drag and pull, I can actually see a closer, so let me do that again, just in case for those of you wanting to see. So if I just want to see just this last part, I'll hold my cursor down, pull forward, and then that will give me a snapshot into what's going on here. So another way to think about this is here's the prediction through December 22nd, okay, or if it thinks of it in December 22nd. Alteryx doesn't actually use your actual dates. It uses kind of a proxy for dates, but it still actually will work just fine. And then what we see here is here's what Alteryx is predicting for the next 14 days. will go on in my data. And then here's the other part: is this blue is actually these fitted values are the predicted sales for that item for that day, and then the gray is the actual. So we can see, how well we're doing in this ARIMA model for probably this is about 30 days worth of analysis of actually modeling that change in the sales across the 30 days. So if you can see what's happening, the ARIMA model is somewhat normalizing these pretty broad jumps, all the way from 10 all the way up to 30. There's a little bit of a normalization in this prediction. And so that's kind of what we're seeing in this ARIMA model. And then this blue line here in the middle, that's what we're predicted. And then here's our 95% confidence intervals are way out there. So if you can kind of tell, this ARIMA model is probably not functioning all that great, because we did see that if we're looking in here, there is a high seasonality trend. I mean, this section here looks a lot like this section. So that should be our first indicator that we probably need to run an ETS model. And so I tell you what, we will go ahead and do that. So let me get out of this screen. And then on here, I'll go ahead and pull that ETS model down. And again, we want to connect to that same data stream. And then we're going to set this one up to run exactly the same way. So the target field is going to be sales, and then we're daily looking at this. And then also for the other options, we want to predict out 14 days, just like we did with the ARIMA model. And then I'll go ahead and add all the browsers. Okay, so now that those are added, and Alteryx likes that, and we'll go ahead and click run, and then we'll see the results from the ETS model as opposed to the ARIMA model. And then you'll start to see probably going to get a little bit better results, but then we'll actually use a tool inside of Alteryx to tell us which one really is working better and which one is functioning better, and then we can use that to forecast on into the future. Okay, so this is almost done. There we go. Okay, so now let's look at the results from the ETS model. So pull this up in new records. So, and in the ETS, we're seeing again, this is those observed scores, and then here's kind of a normalized way of looking at that across time. This is saying like an overall baseline without these seasonal trends. What will we look at? And then what we're also going to look at is, again, here's that good seasonal component. If we wanted to see just a part of that, we can actually do that with the next chart that we're going to see. But there's a forecast plot, and you notice those lines. If we really focused in, we would see that the forecast plot, these lines for each day, those are including our confidence intervals, they are huge. And so we're having trouble still with this. This is a tough data set to model. And then here's the other stuff that we're going to use, the AIC, the BIC, the MAPE. We're going to use those numbers to compare against the ETS. But let's look again at more of the output of this ETS. There we go. So we pull this up. We can do kind of the same things that we were seeing before. That here is, again, just the plot, just like we saw from ARIMA. And if we wanted to pull in just that section, we can see these plots here, they're actually doing a better job of kind of capturing probably what we're seeing through the week for each of these. But if you'll notice, these hills and valleys, they tend to, the section from here to here tends to look like the section from here to here, look like the section from here to here on our predicted, because it's saying, hey, treat this as a seasonal trend or more of a seasonal trend. And so that we are seeing seasonality within each week, and then try to apply that to this model. And so we kind of model the same type of seasonality, but then it's adjusted up and adjusted down. And as you can tell, it is doing a bit better of a job to capturing what we're seeing in the actual data set. And so, but this really highlights, I think this graph really highlights the difference between what you're seeing with an ETS tool and what you're seeing with an ARIMA tool. Okay, so I'm going to back out of this, and now we want to do, okay, now we really want to know how are our models different from each other. And so what I have to do first is I have to join these models together in a union. And so I'm going to pull my union over here. I'm going to take the output node from each model, or the output anchor, and then pull those in. Oh, I need to fix one thing though. I believe I named this model ARIMA, but I did not name this model, and so I'm going to name it ETS so that in our output we'll be able to tell the difference between the two. Okay, so both of those are union together, and then we're going to go back into our time series tool, or our time series tab here, and then with this TS compare, that's going to allow us to look at the differences between these two types of models. So in the left anchor, I'm going to have these union models, and then in the right anchor, I'm going to include those 15 days that I held out. So those are 15 days of actuals. And so what this tool is going to do is it's going to say, all right, give me the weights and the outputs from these models, and then I want you to apply them to these next 15 days, and then I want you to compare the two models, or 14 days. I want you to compare the two models on what they're able to do and how well they're able to predict, and then that would give us a good idea on which model is working best. So I'm adding all those browsers to the end. Go ahead and Alteryx hung up on me again. Go ahead and hit run here in just a second. I'm having all kinds of computer issues. That's wonderful. Sorry about that. So Alteryx is coming up. Come on. I think there's a hang up here. I'll tell you what, while it's hanging up, I want to talk through the rest of the tools that are in this tab. So you have your ARIMA and your ETS, and we're now doing the TS compare. That's one also. The covariate forecast, and then actually including covariates, I'm not going to take the time to talk about today, but this is if we did in the ARIMA and the ETS modeling, if we did actually pull in some of those models and we did include covariates in our model, this would be a good way we would use this tool here to forecast those covariates out into the future. This TS filler we've already talked about. That's the tool for pulling in any type of output. So that's the tool for pulling in when we have, let's say we have 6 days of data, we're missing the 7th each week, we might use that, or we have some days where someone just forgot to sample the data that day, then we'll pull that in. And then we'll talk about the TS forecast here before we finish out today. And so, goodness, my computer is, oh, there we go, now it's working. Alteryx was completely locked up there on me, but now it seems like it's working. So now as this is running, again, we're going to use those two models to actually push out the prediction for those next 14 days, and then we'll see, all right, based on that, who does a better job. So it takes just a second to run. And then as it finishes up, we'll talk about the results and how we interpret those things. Great, okay. So the first is to look at these. And so what we've done is, here are those next few days. And what we're looking at is the actual score, and then how the ARIMA predicted, and then how the ETS predicted. And so you see on this first one, the ARIMA did a bit better getting the actual. On the second one, the ETS did better. Then the ARIMA did better, and then the ETS did better. And so what then these measures down here do is they tell you which one's actually doing the best job across time of actually looking at these predictions. So if you can tell, really, I'm probably going to look at the MAPE is usually the one that we would want to consider across all these, and you can tell they're right on each other. So 40.9 versus 40.4. And so you can probably go with either one. But again, here are those, the ARIMA and the ETS, and here, even though if we had much less data, it would be kind of easier to see. But in this case, we're because at the very end, we have so much of this data in the past, it's hard to see that. But I thought what would be nice is what if we could go ahead and fix that? What if we could go ahead and say, all right, let's use less data. Let's suppose we're predicting the next 14 days, but really what we want to do is only use, let's suppose we only had access to 30 days before. So let's do this. So let's say that date time is less than December 15th, but we'll add a and in here, and then date time, oops, there it is, the date time is greater than or equal to, and let's do 2017 -11 -15. Okay, so we have a month's worth of data. Let's say that that's all we have that'll be feeding into these streams. Is we have a month's worth of data, and we're going to use a month's worth of data to predict the next 15 days. And let's suppose that's all we had, and we didn't have all this historic data. And then we can rerun it. And so this is the reason we're doing this, is this to just give you an idea for how this ARIMA model, or the ARIMA and the ETS, would compare to each other given shorter run streams. And so meaning we had a whole lot less data in order to consider in our analysis. And so so we'll go ahead and run these. They actually will run a lot faster, but given 30 days to try to predict 15 days versus given 3 or 4 years to try to predict 15 days, kind of how are we doing? And again, if we go to this output here, these graphs will be a little bit easier to interpret because they won't be quite near as big, but that graph is rendering coming up. We should see it. Okay, so here's actually predicting those next 15 days again. Oh, I may have put the wrong thing in there. Sorry, I ran my filter incorrectly. I'm at, so the true coming out. Sorry, I should have actually added another filter in there. So that would be for the, sorry, I should add another filter going into here, where that says that date column, because otherwise it's pushing everything out there, is greater than or equal to 2017, and that should be 12, 15, 16. Okay. So the problem was I was pushing everything into the be predicted part. So we definitely don't want to do that. And so now we have just those 14 days coming through. So it should be, yeah, it's greater than or equal to. And again, waiting on Alteryx, trying to come back up. I'm assuming this has something to do with, I've just noticed this recently, and I just upgraded my Mac OS, but as this is coming through, so that should be a much smaller group here. So now we've got the 31 days pushing through here, and then we should have just the 15 days pushing out of this one, okay, or 16 days. And so as that's finishing up, now again, we can look at the output of this, and that's right. Okay. So there's our data, if you can think about this. So, and the problem that we're seeing is that the ETS is just not looking at enough, and this is the reason I wanted to show you this, is that the ARIMA is saying, look, I just want to consider, or, consider the last few days in order to predict the next few days. But what's happening is the ETS is basically saying, I just don't have enough information to notice any seasonality trend. And so each day it's just predicting the exact same score, which is 17.609.42, 17.609.42. And so again, we're seeing in this is that, and the reason I wanted to show you this is that you may want to use an ETS model and say, yes, I see there's seasonality, but I have a very small data set, let's say just a month's worth of data. And in this case, there's just not enough information in that data set for the ETS tool to actually say, all right, we are seeing seasonality and we're noticing it going forward. And so it's going to predict the same score across time, which is probably just really close to the average of those last few days in order to predict the actual time going forward. Okay, so I just wanted to show you that because I think that that's actually a pretty interesting way to look through comparing the two models. And so again, we would want to compare them with our entire data set, not with this smaller, but it is a good way to consider those. So I tell you what, I'm going to get rid of some of this, and we're going to say, all right, indeed, we want that that ETS tool, and now we want to predict what our data is going to look like, let's say, for the next 15 days. Okay, so again, we're going to pull in the time series, pull in the time series tab, and now we have this TS forecast. And I tell you what, we'll go with the ETS model this time. So I'm going to go ahead and delete this just for time's sake. And so I'm going to again grab that output anchor. I'm going to pull it in to, this is my TS forecast tool, or time series forecast tool. And then let's configure that tool. And so it's going to create a value or a field for us called forecast. And we want to forecast, let's say, 14 days into the future. And so I'm going to make these confidence intervals are set from 80 to 95, and that's fine. We'll just leave it at that. And then we got to add all our browses there at the end. There we go. And then now that that's done, again, now we're going to run the model. And what this is going to do is it's going to say, all right, given all this data and what we have done with this ETS system, and actually building a model, use that model and all the information contained therein to actually predict the next 14 days forward, and tell me what you think. And again, I made a mistake. That was a bad on my part. I need to fix this filter again. Sorry about that. Let's turn all this stuff back off so it uses all that past data. And let me run that again. Sorry about that. Should have thought of that ahead of time. But now we're using all this past data, so 1,810 observations to build the ETS model, and then we're going to predict 14 days into the future. And we'll see kind of how this tool works and how we could use this going forward. And so this is kind of taking you all the way through. We built the model, we like our model, and then we want to see what it looks like going forward. And so here's our graphic. So there's all the data in the past, and there's predicted going forward. Now, again, it's hard to see there, but this is where we would actually want to just hang out and stay. So what this is telling us is that for the next day in this series, for the next day, we are forecasted to sell this item 21 times, and the day after that 22, and then we'll drop down to 14. And then we'll go back up to 17, 17.9, and 18. So you can see there is a bit of a seasonality trend here. So there's, again, that subperiod 5. And if you notice, that is remarkably similar to this subperiod 5. And then 6 is remarkably similar to 6. And then 7 is remarkably similar to 7, because we told it, notice seasonality, and what the ETS tool is saying, hey, I'm seeing some seasonality, not just across years, but also within the weeks. And so a Saturday, what it's saying is a Saturday looks like a Saturday, and a Sunday looks like a Sunday, and a Monday looks like a Monday in terms of sales. But you'll see that those differences start to dissipate as we go across time. Okay, so they'll start to actually a little bit regress towards the mean, and if we're starting to push out, but then push out even further in our predictions. But another way to think about this is that, yeah, we think it's going to be about 21, but the high and low forecast at 95% confidence intervals is 31 all the way down to 11. But if we think of 80% confidence intervals, so we're 27 all the way down to 14. So that's how certain we are of that number. And as you can tell, we're not crazy certain, moderately certain in this case. And so that gives you an idea of that's your score that we're predicting going forward from this point forward. And then there's some thought around how stable we think that score is. And then also, if we want to look at this last graph, we can get a little bit more information about what's going on here. And again, the reason I like this graph is because now I can click and I can say, all right, let's just look just at what's happened over the last few weeks. And again, the blue line is the fitted, the gray is the actual score. So there's our scores going forward. And as you can see, there's that same trend. There's a trend to there, 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 and then we're going to keep that trend going forward because we're using the ETS, and this is, we're assuming that that trend is going to continue. Okay, so that is a little bit like drinking from a fire hose. That's a whole lot of information about time series, but I'm going to go ahead and stop, and I'm going to turn it back over to Rachel, and if there are any questions. So, okay. Well, Rachel's giving me the nod no that there aren't any questions, but I will say thank you for joining us on this webinar. I know you'll probably want to, if you want to go back and watch this again, this is a whole lot of information in a really short amount of time about how to do time series. But again, hopefully we've given you all the tools and how you think about ETS versus ARIMA, how you can compare them, and then how you can do your predictions going forward with this TS forecast tool. And just to let you know, again, there's some pretty great graphs in here inside of this to where you can now say, all right, Alteryx, I want to see going forward kind of what my trends look like across time. Okay.
Awesome. Thank you so much, Kyle. The link for this webinar will be shared before the end of the week. And we just want to take a moment to say thank you so much for participating in this series. It's really been a joy for us. We'll be sending out a survey within the next week or so, and we'd love to hear feedback on what you loved about the series and if there's any topics that weren't covered that you guys have interest in covering in 2020, we'd love to hear it. Again, all of these resources are located on our website, so feel free to reach out to us if you have any other questions. Thanks.